In the previous lecture we talked about object-oriented programming in F# and how to write classes, how to do abstract methods, how to do overloading, and so on, polymorphism. And that's only half the story. So now we're going to cover the other half of it, and this is where I personally find that most of the gold is, and this is how to define interfaces. Some languages call them traits. And what interfaces allows us to do is to say, okay, here is a specification of some functionality that you need to implement. And then you can implement it, and now you can write code where you can put constraints on things to say, I can accept whatever as long as it implements the following interfaces, and then you can list the interfaces that you want. And this is very useful. This is very, very useful to make type-safe code and to make it actually useful. Problem with having if you write a function or a container with a completely generic variable, so you just say blah a. We know absolutely nothing about a, so we can't do anything with it. We can sort of put some structure around it. We can pass it around. We can do all of these things, but we can't actually use any properties of this thing. And interfaces allows us to say that, well, this is some whatever, but you can do the following things with it. So that's why interfaces are very, very handy. Okay. So in the previous lecture we saw how to define a class. So we could say type, contact, parentheses, constructor arguments, ta-da. So by having these parentheses we created a true class. But F# actually allows us to put methods and all of these things on not just classes, but any type really. So we can have them on record types, and we can have them on union types as well. So actually I can do something like this, type, and now I'm going to do another contact. So there's a contact, and in order to save myself some typing again, I'm just going to do it really simple. I'm just going to make a record type, and I say okay. First, well, a full name. That's the only member of this record type, right? So this is just plain simple record type. But now I can say with, and for example, static member default. Equals, and then we just create the contact. So I'm going to say full name equals hello. That's the default full name. So now I can say, now I can just take this record type and say, you know, contact.default, and it will give me the default version of it, which is very convenient because a lot of the time you can have complicated record types with many members, and it's super tedious to work with them in that way. And then you can just create a default, sort of a default constructor for it, which will fill in all the blanks, just make it, and then you can just use this record update syntax to update that thing and put in the stuff which is non-default. And this is something we do a lot. Now, of course, there's no, like, I could just take this, instead of say static member default, I could just put this outside and just create a let default contact equal, and then just produce this thing and just define it. It would be the same thing, but this sort of makes them slightly more tightly coupled. They belong together. So this is a kind of logic thing to do. Like we can have just a function to construct an object, but it's sort of a little bit more natural to have this thing, the constructor of the object, coupled to the class. That's sort of the philosophy here. I can also have normal members. Member this show equals well, this full name. So now I can actually refer to this particular record that you have by through this name. Again, of course, I could just do it in the way that I could just do it so that I would pass in, make a show function which takes 2 arguments instead, or just takes 1 argument, which would be the record that you have, and it will show it. But this is, again, potato. But this just shows that how to do this, and that you can have these members. But the nice thing about this is, and the stuff that you can't do with normal functions, is that you can actually now you can do overloading on them. So we can have a default which takes no arguments. We can have a default which takes some arguments, and so on and so on. And we can actually, and that's not available if you don't use this syntax. So that's a case where this is really useful. And similarly, I mean, I could just have turned this into a union type of string, and it would be the same. It doesn't matter if it's a record type or a union type. And I could have all the cases, but of course I need to pattern match here. So this just a little caveat. Okay, so interfaces. The way we define an interface is we say type, surprise, surprise, I contact info, or whatever. And while this is not strictly compulsory for interfaces, the linter and Visual Studio will complain to you if you don't have it. It's customary to have a capital I to say that this is an interface. Equals. So there's no parentheses here now. I'm not defining a class. And in order for this to be an interface, all its members need to be abstract. There can be no implementation whatsoever. If I would do the same thing and I would put parentheses here, I'm just abstract, then I would make an abstract base class of things. But then you actually need to, there's a technicality, and then you need to add an adaptation and so on and so on. And you can read about this is in the manual. If you're really deep and hardcore into doing abstract base classes and stuff, then read up on it. I'm just going to do an interface. So now I can say abstract member, and I'm going to call it, let's just say that for sake of it, I'm just going to take this show feature and put it into this eye contact info show, and that's a function taking unit, producing a string, and that's it. So it's a super simple interface, one abstract member on it. And then I could take my contact from the previous. So I could say the type contact equals full name string that we had previously. And now instead of and now instead of doing with abstract member and blah blah blah, I can say interface I contact info with member this dot show equals this dot full name. So now I've implemented an interface on this thing. And that means that now I can actually use this interface in places. So given suppose I have a let C equals like this, and the compiler will say that okay, this is a contact, and I want to run the show thing on it. I can't say c.show because this is a contact and not an iContact infos, and this is a little bit of an annoyance. I think the compiler could figure it out for us, but for some reason it doesn't. So I need to do, if I want to call the show on it, so I said let c string equals, I need to say c upcast to iContact info dot show. A bit annoying, but c'est la vie. So, a few more things, and we're sort of through this object-oriented swamp. When dealing with interfaces, you end up sometimes implementing a lot of interfaces for a lot of objects, and going through all of these hoops and doing interface, it becomes kind of again tedious. So they figured out that they provided some syntactic sugar, and this is quite nice actually for implementing interfaces. And if you want to implement multiple interfaces, you can go and look at the reference manual how to do it. It's simple, but you can have multiple, of course. But let's look at what is called an object expression in F#, which allows us to sort of implement an interface on the fly. So let's make a pretty contact function, just normal function, pretty contact C, and this is some sort of contact object that I get. Now I can say curly brace new iContact info with member the, was it that like that? Yes, it's like exactly the same. Remember this show equals, and then some implementation of show. Yes? So that's how you can just implement this interface on the fly. Okay, right. So let's look briefly at what was more? No, okay. Oh yes. Two things. Oh. Actually, I'll combine these two into one thing. Save myself some typing. So now we have we take the contact type. It doesn't matter if it's a class, it doesn't matter if it's a record type, union type, we have this contact. And we have some members on it. And Now I would like to extend it somehow. And then we can use a so-called extension method. So it actually allows us to take a thing which is pretty much defined somewhere else. It could be in a different module, it could be in a different assembly, somewhere we have a type or a class, and it has methods on it. And it doesn't have the one I need. So instead of inheriting and adding on top of it, I can just extend it in a very simple way. So the way I can do it is I can say type my contact, no, sorry, not my contact, type contact with let's see, where did I have the, so just, I don't write anything wrong. Oh yeah, so yeah, this is it. So instead of saying type contact equals something, I say type contact with. So this is the key thing here. And now I can say member this, and we can have a function, what should we call it? Show and see. And now I'm going to use a interface constraint on this thing. This is going to be a little bit contrived, but it's going to sort of show the point. So I'm going to say that this fancy here is going to take a generic argument. In addition to having access to the object itself, it's going to have some generic argument to it. So I'm going to say some, let's call it t. And this is how you normally would make a generic function of some. So I could say x of t equals. This is how you could normally do a sort of generic function. But now I'm going to say this is going to take a generic argument when, and I'm going to have to take a new line here, but when t implements I contact info. And there's a whole bunch of these, and they can be ANDed and ORed, and you can require them to have static methods, and you can require them to have certain types of constructors, and you can, like, all kinds of things. So there's a long list of requirements how you can. So this is just scratching the surface of this wonderful world of type constraints. And then I can say, okay, so this thing takes a variable x, which is of this type t, equals, and now I can do whatever I want inside this body. For example, I can say, this dot full name, and then I can say plus space plus x dot show. Because now I know x has implemented this iContact info, which provides me with the show method. If I didn't have the constraint here, I couldn't do anything with x. Nothing. Because I don't know really anything about it. I could add it to a list perhaps, but that's it. Yes?
So this was extending an interface. It's only extending interfaces now.
No, this was the risky bit, because I did extension methods and the generic interface constraints. So there are two things going on here, and that's a good question. There are two things going on here at the same time. So one is extension method, which is just, you can just plug any method that you like here. And the other thing is that I have an interface, and it's defined, and it's locked, and it's there, and yeah, that's it. I'm not extending it. I can't extend interfaces. And then I'm just saying that, okay, I'm just going to make this generic function, which takes a generic x as a argument and does something with it. And in order to do something with it, I put on some constraints so that I know what I can do. And in this case, I'm just saying it needs to implement eye contact info. And this means that now when you try to call this thing, if the X that you are using is not implementing this interface, then the compiler will say, nope, nope, this is an error. So there are two things going on. Yes?
And the type contact was that previously defined?
That was previously defined. So the type contact here is just the contact, whatever, either the class we defined or it doesn't matter. We can extend classes, we can extend record types, we can extend union types with methods. We can't extend the number of elements in a record type or the number of cases in a union type, but we can add more methods to it. So I think this is more or less it. I should though point out that these things are also very well documented in the F# language reference, so you can go and look up these things. So there's a lot of detail to this. But once you have the sort of basic idea of how things fit together, then it's pretty straightforward. Right. So that really concludes part 2 of this course, which is sort of according to the 2080 rule. This is the 80% of the usefulness of F#, and then there's a lot more to know, and there's a lot more that I'm not talking about, but you are quickly getting into the crust, really. So we are just pulling out the soft, mushy, delicious interior of this language, and then there's all this hard stuff out at the edges that when you get really hardcore, you need to look it up. Typically how it works is that you work with your language and then you realize that there's something is starting to hurt. And then you start going to Stack Overflow, or you start digging through the manuals, and then you find out that, oh, you can actually do this. This is pretty cool. And then you learn new things. But that's it. From now on, well, I shouldn't say that. The next session, the next part of this, will be sort of part 3, will be distinct again from the previous 2 parts. We will return a little bit more to the theoretical stuff and look at abstractions, and in particular composition. Composition. And composition will then continue throughout this course to be a central theme. And as I said earlier, the last part will be writing web client-server web applications, multi-threaded, parallelized, everything compiled to JavaScript, reactive programming, asynchronous stuff, all kinds of cool things. But first we'll do a little bit of composition, because that's hugely useful and very fun. All right. Until then.